These examples and notes are for the sum and difference formulas. The sum and difference formulas are complicated, and you do not need to memorize them. If you were to use them plenty of times, you would not have a hard time memorizing. There is a pattern to these. And as I do problems, I always write down the formula I use, and it does help me memorize them. So my first example, I want to just see if sine pi over 6 plus sine pi over 4 is equal to sine pi over 6 plus pi over 4. So what I do is I set this up as an equation. Sine pi over 6 plus sine pi over 4. I want to see if it's equal, so I have a question mark over my equal sign. Sine pi over 6 plus pi over 4. I substitute the left-hand side. Sine pi over 6 is 1/2 plus sine pi over 4 is square root of 2 over 2. Once again, I want to see if it's equal to, so I have a question mark. This side I have to use the sum formula. So sine pi over 6 cosine pi over 4 plus cosine pi over 6 sine pi over 4. The left-hand side, I can rewrite this. They have a common denominator, so I write the numerators together. The second side, I'm going to go ahead and replace sine pi over 6 with 1/2. I replace cosine pi over 4 with the square root of 2 over 2. I replace cosine pi over 6 with the square root of 3 over 2. And I replace sine pi over 4 with the square root of 2 over 2. I don't do anything else to the left-hand side, but my right-hand side now, I'm going to go ahead and I multiply these two. Numerator times numerator, square root of 2. Denominator times denominator is 4. Square root of 3 times the square root of 2 is square root of 6. 2 times 2 is 4. So the left-hand side does not equal the right-hand side. My second example, I want to just go ahead and evaluate cosine 3 pi over 4 minus pi over 3. So my first step is I identify what u is and what v is. And I expect all my students to write this down on their paper. I wrote the formula here. It's at the top of my page, but I usually write these at the top of my page or with each problem. I don't require you to do that, but it does help me. So then I just replace all the u's with 3 pi over 4. So cosine 3 pi over 4 and sine 3 pi over 4. I replace all the v's with pi over 3. Cosine pi over 3, sine pi over 3. I expect all my students to write this step here with the u and the v, this step here where you replace the u and the v with the angles. Then I write cosine of 3 pi over 4, replace it with negative square root of 2 over 2. I replace cosine pi over 3 with 1/2 plus sine of 3 pi over 4 is the square root of 2 over 2, and sine of pi over 3 is the square root of 3 over 2. When I multiply these, I get negative square root of 2 over 4 plus the square root of 6 over 4. It's okay to leave it like that. I just tend to write it so there's one fraction. The denominator is the same, so I can write it like that. And I would check it with my calculator. I would go ahead and I would figure out what the cosine of 3 pi over 4 minus pi over 3 is, and I'm going to get a decimal. And then I figure out what this decimal is, and as long as they're the same decimal, then I know I did it right. My third example is going to be tangent. Tangent tends to be the most difficult one for students just because you're using fractions. And it's the algebra that's complicated with it, and you have to practice. So once again, I identify what u is, I identify what v is. I write the formula once again here, and then I go ahead and substitute. All the u's get to 2 pi over 3. All the v's get 5 pi over 4. The next step, everyone should be good enough at by now, you're using your unit circle and the information from your unit circle. So the tangent of 2 pi over 3 is going to be negative square root of 3. And the tangent of 5 pi over 4 is a positive 1. And I replace all the terms. This is really important. If you get it wrong here, you're going to get the whole problem wrong. So make sure that you do have your values correct. when I go ahead and multiply down here, I'm going to get up 1 plus the square root of 3. So my denominator has 1 plus the square root of 3. In most instances, I do expect students to rationalize the denominator. This is a skill you learned in Algebra 1 and practice in Algebra 2. To rationalize the denominator, you have to multiply by the conjugate of the denominator. Since this is 1 plus the square root of 3, the denominator rationalized is going to be 1 minus the square root of 3. But I have to multiply both numerator and denominator by that because I have to multiply by 1, which does not change the value. It's only going to change the appearance. When I multiply slowly, multiply each term. So negative square root of 3 times 1 is negative square root of 3. Negative square root of 3 multiplied by negative square root of 3 is going to be a positive 3. 1 multiplied by 1 is 1. 1 multiplied by negative square root of 3 is negative square root of 3. Same thing with my denominator. 1 multiplied by 1 is 1. Then I have a negative square root of 3 and a positive square root of 3. These terms are going to be 0. That's what you want to happen when you rationalize the denominator. And then positive square root of 3 times a negative square root of 3 gives me negative 3. When I clean this up, I get 4 minus 2 square roots of 3 divided by negative 2. I can reduce this fraction. 4 divided by negative 2 is negative 2. Negative 2 square roots of 3 divided by negative 2 gives me a positive square root of 3. And then once again I would check it with my calculator. I'll do another example with tangents, since this is the one that most students have a difficult time with. So the first example was plus. This is going to be tangent pi over 6 minus pi over 4. So once again, I identify u and v. I write my formula down. I replace the formula, all the u's with pi over 6 and all the v's with pi over 4. Then I find what the tangent of pi over 6 is, and I find what the tangent of pi over 4 is. Replace all the terms. I simplify the terms here, so when I'm multiplying these two together, I get the square root of 3 over 3. At this point, you could rationalize the denominator, and I have some students who can do this successfully. I just like to clean it up a little bit. I don't like all the fractions, so I'm going to get a common denominator. So I get the square root of 3 over 3 minus 3 over 3. That's my 1. I get 3 over 3 plus the square root of 3 over 3. So 1 plus the square root of 3 over 3. Once I do that, I get a common denominator of 3 here and a common denominator of 3 here. When you divide fractions, you reciprocate the second fraction, so you flip the second fraction and you multiply. What's going to give you is a 3 in the numerator. This will become the numerator. This will become the denominator. 3 over 3 is 1. So that gives me the simplified version, the square root of 3 minus 3 over 3 plus the square root of 3. I can then rationalize the denominator by multiplying by the conjugate of the denominator. There's all my multiplication. I clean up combined like terms, and then I simplify. And then I would check it with my calculator to make sure I was right. I have 2 more examples. The other way that you can see this in the textbook is by given information. So I'm given sine of u is equal to 2/3 and cosine of v is equal to negative 5/8. And I'm told both angles are in the second quadrant, and I want to find cosine u plus v. So I'm actually going to draw the angles. So angle u, the sine of angle u is 2 over 3, it's in the second quadrant. And I can find the missing side. And I know the missing side is negative. And that's why I draw this in the correct quadrant. I would put negative square root of 5 here. For v, I'm given cosine of v, so I know the adjacent and the hypotenuse, negative 5 over 8. I could find the missing side to be the square root of 39. And just for my convenience, I go ahead and write the formula again. Then I can look at my diagram. I'd have cosine of u, so I make sure I look at here with u. I have cosine v, I make sure I look here at v. Minus sine of u, so I look here for sine of u, which is 2/3. And sine of v, I look here for sine of v, which is going to be square root of 39 over 8. I multiply my terms together. So a negative times a negative is going to be positive, so I get 5 square root of 5 over 24. Minus 2 square root of 39 over 24. I can leave it like that. I'm just going to go ahead and write it as one fraction. And then to check this with a calculator, what I would do is I'd actually calculate what u is, the angle. I would calculate the angle of v, and I would get the decimal approximation for cosine u plus v. Then I would get the decimal approximation for this, and I would check to make sure they were right. The last example is just a matter of recognizing the formulas. So what I look at is I have this angle, this formula with sine and cosine, minus sine and cosine. And the formula that does that is going to be sine u cosine v, cosine u sine v. So then I could recognize u is equal to 3 pi over 8, and v is equal to 2 pi over 5. So that means u plus v has got to be 3 pi over 8 plus 2 pi over 5, get a common denominator, I get 31 pi over 40. So I know that this is going to be sine of u plus v, and u plus v I said is 31 pi over 40. So this equation up here, this expression up here, is equivalent to this one here.